Have you ever tried to wish something into existence? Well, we live in a world where you can practically do that now. We're not talking about a magical genie. We're talking about 3D printers. If you can think it, chances are you can print it. From 3D printed sushi to 3D printed organs, here's a rundown on how 3D printing works and how it's changing our lives. You're watching The Deets, a show where we demystify the technologies that are shaping the future. I'm your host, Riley Wynn. 3D printing is one of the most revolutionary technologies of the 21st century. But what you might not realize is that there are tons of different 3D printing techniques out there. Today, we're going to talk about the four most common varieties: FDM, SLA, laser sintering, and PolyJet. There are some other more specialized methods, but these four are definitely the most widely used. Let's start with FDM, which stands for Fusion Deposition Modeling. If you've seen a 3D printer in person, then chances are it was an FDM printer. So how does it work? Well, functionally speaking, an FDM printer works a lot like a hot glue gun that's being operated by a robot. Solid material known as the filament goes in one end, gets pushed through a hot nozzle, it melts, and is deposited in thin layers. This happens over and over until a three-dimensional object emerges. So, in other words, FDM 3D printing is basically 2D printing over and over again. Just each time a layer is completed, the nozzle moves up just a little bit, and the next layer is printed on top of it. Then, there's stereolithography, or SLA. Here's a mind effort for you. SLA basically uses light to grow objects out of a puddle of goo. What? Yeah, exactly. SLA machines work by shining ultraviolet light into a pool of photoreactive resin. Any resin struck by the light solidifies and forms a layer of the object you're printing. Generally speaking, these printers can create objects with far finer details than FDM printers. The third variety of 3D printing is laser sintering. LS prints by flashing a high-powered laser over a bed of superfine powder, fusing the particles together to form a thin solidified layer. The machine then sweeps more powder over the top of that layer and repeats the process until the 3D object is complete. This process isn't common in consumer-level 3D printers, but on the industrial side, it's often used to create large, durable objects out of metal. In fact, SpaceX uses this method to 3D print its Super Draco rocket engines. That's definitely a tough act to follow, but we've got one more on our list. Last but not least is a 3D printing technique known as PolyJet. Think of this one as a mix of FDM and SLA. PolyJet machines squirt out tiny droplets of photoreactive resin onto a build surface, and then immediately harden the resin with ultraviolet light. This process is then repeated hundreds of times to create objects from the bottom up. The benefit of this method is that it's crazy fast and super precise. Unfortunately, most PolyJet printers cost tens of thousands of dollars, so they're out of reach for people like you and me. Now that school is over, let's talk about the real world, because 3D printing is used in almost every industry out there. One awesome example is how 3D printing has completely changed the world of prosthetics. The thing about prosthetics is that every limb needs to be customized for each individual, which makes prosthetics difficult to mass produce. With 3D printing though, you can scan a person's body and then 3D print a prosthetic that's tailor-made to fit the unique geometry of their body. There's even a startup called Print My Leg that provides open source blueprints for prosthetics. They allow others to create decorative prosthetic leg pieces that they can make as an extension of their own personalities, no different than getting a tattoo sleeve or choosing clothes that capture some aspect of your personality. That's just the tip of the iceberg though. We're not only printing limbs now, we're 3D printing organs too. Scientists have successfully 3D printed a mini human heart from stem cells. This heart is partially functional and is used for pharmaceutical research. There are a few challenges ahead in making it fully functional, but the scientists are confident that in a few years, this 3D printed heart will be able to function inside an animal or a human. This technology could be used to create thousands of much needed hearts for transplant surgeries. Enough about medicine though. Let's talk about shoes. Nike is running away with 3D printing technology. The company recently introduced Flyprint, a 3D printed textile upper for your sneakers. It's the first of its kind and it may bring about a new standard in performance running shoes. Because they're 3D printed, the shoes can be rapidly customized and produced for specific sports or specific athletes. And the shoes can be prototyped 16 times faster than traditional shoe making methods. 3D printing is even making its way into the construction business these days. It takes Extreme Home Makeover a week to build a house, but with 3D printers, you can build one in a single day. Nonprofit startup Icon invests in affordable housing solutions. These houses are 800 square feet and cost less than $5,000. With 3D printing technology, they're able to provide housing in poorer communities cheaper and quicker. But what if you want a boat in the driveway of your 3D printed house? Well, as Vince Vaughn would say, it's not a boat, it's a yacht. Naval architect Greg Marshall wants to start 3D printing super yachts. Marshall says that you could print an entire super yacht in one go, including the interior. A 150-foot yacht usually takes 2 to 3 years to build traditionally. Marshall claims that you could 3D print that same yacht in as little as 90 days. Hollywood has even hopped on the 3D printed bandwagon. Showbiz is using the technology when it comes to set design and prop making. 3D printing allows studios to create custom props quicker and cheaper than traditional methods. Leica, the animation studio behind movies like Coraline and Kubo and the Two Strings, uses 3D printing to create all the set pieces in its stop-motion films. Does your mouth water at the prospect of a nice juicy steak? How about a 3D printed porterhouse made using a paste composed of vegetable-based materials like rice, peas, and seaweed? Yeah, no thanks. But that's what a new Spanish startup, Nova Meat, is working hard to bring to market. Left and right, different foods are being printed. Sushi, burgers, the list goes on. These foods aren't being produced just for publicity. There soon could be an actual need for 3D printed food. The global population is expected to grow to an estimated 9.6 billion people by 2050. And some analysts project that food production will need to be raised by 50% to maintain current levels. How we currently produce food isn't going to be able to keep up with that demand. And 3D printed food may be the additional production method we need to keep from going hungry. The really exciting part is that this is just the beginning. The earliest 3D printers were invented just a couple decades ago, and despite the fact that the technology has advanced in leaps and bounds in that time, it's still very much in its infancy. Today, we're printing organs and rocket engines. In another decade or two, there's no telling what we might be able to create. Would you eat a 3D printed steak? Let us know in the comments below. Until next time, I'm Riley Lynn with Digital Trends, and thanks for watching.